Okay, there we go.
Okay. All right. So welcome everyone to our second engineering workshop. Today it'll be hosted by Eric, our engineering lead, and it's going to be about REST API design. If you guys don't know who we are, we're TPO, Text Product Engineering Organizations. We've hosted one previous workshop this semester about recruiting, and on April 14th, we'll be hosting a workshop on cybersecurity. So yeah, Eric, take it away.
All right. Okay, so today I'll be talking about basically REST API design. Like I'll start with like what is an API, and then I'll get into requests, responses, and then all the things you can do with those. And at the end, I'll do a little bit about how to like paginate results and that kind of stuff when you get into bigger stuff, bigger APIs, right? Okay, so first, like what is an API basically? So it's the interface between the client's computer and the server, right? So basically the client is the phone, like or the laptop that the user of an app is going to have with them to use the app. And then the server basically is in some data center, and that's owned by the company to serve up the back end of this app, right? And the way they communicate is through this request response kind of action. So the app on the client will send a request to the backend server, and then the backend server will send back data that the client requested, and that happens over HTTP. And usually the way that the data is exchanged is in JSON JavaScript object notation. So if you see on the right here, it's basically just key value pairs with strings and numbers, right? And one thing to remember is that it's always the client that initiates the communication with REST. Like there are kinds of things you can do to make it so that like there's a continuous connection for, like video or other things like notifications where the server actually initiates the action. But for REST, we're just going to be focusing on only the client being able to make requests, right? Okay, so what is REST? REST is basically just a way to design APIs. It's like conventions that make it easier to extend and build APIs. And like basically like the kind of reason behind it is that you basically have asynchronous development, right? You have full control at any time of what goes on your backend servers, but then the clients that you send out, right? When you send out your, old version of your app, there's no guarantee that your client is ever going to update to a newer version when you release a new version, like if they ever do, right? So, with some of these like companies, like some companies, like they have like really old versions of their API, and you'll be able to see like like maybe like 80% of their users are on the most recent version of the API, and maybe like 20% on the next older one, or I mean like 15% on the next older one. And then there's like 5% of users that like have a really old version of the app, and then they still have to keep that different versions of the API around. But REST basically just sort of lets you try to minimize that difficulty. Yeah, Tyler, you have a question?
Yes. Why does REST stand, like, so REST stands for representational state transfer, as you stated on your slide. Can you explain why that is? What does it mean for an API to have representational state transfer?
Sure, yeah. That basically is just describing like the kind of communication that's happening. So like if you set up a request with a body, and then the server responds with um, some data, right? That's basically transferring, state between the client and the server. And right, and that's all represented with the JSON. So that's sort of like what it's just a technical term. It's not really that important to know this term. It's just that's just what REST stands for. Yeah, a few other things. Every operation is self-contained. So right, every so the requests basically have a method, right, and a URL. So every request and response is self-contained. So like if you do a get, like everything that has to do with that get happens within the request and the response, right? There's no like stuff that's left over that's gonna remain, like say like if you do it twice, like there's not going to be like anything related between the two. And yeah, and basically the whole idea of REST is that you manipulate resources rather than executing actions. So for example, you have customers, like customers is sort of like a noun and not a verb, right? You have things, not actions. And for example, even login, like an action, which you think of usually as an action, in REST, you would frame that as creating a session by posting to an API, and that will give you back a token that you can send back on subsequent requests. Okay, and so like here's an example, right? So if you run a GET request and say on your API you have a customer's endpoint, so what that will do, it will give you a JSON list of objects, and each object will be made up of key value pairs that represent the data about each customer. HTTP actually has a whole bunch of methods that you can use. And the helpful thing about the methods are that, for example, for the customers, you can use the same URL and do different things with it, right? So I'll have an example later, but for example, if you get on the customers like before, you can get a list of your customers. But also using the same URL, if you do a post request with a JSON object in the body of a new customer, that's the way you create a customer. And then you actually did not need a different endpoint URL for that, right? Okay, so the most common methods are get, just to get a resource, post to create a resource, delete to delete, and the next two are less common, but they're still like pretty useful. Put is basically a post, except you're replacing an existing resource. So that resource would already be there, but if you run a put, right, that's like a complete replacement of that resource. Like the number of resources you have doesn't change, which is the important thing, which is why it makes it a put, right? So, and then patch would be to say if you had a customer and you only wanted to update their age, right? You don't need to update their name or their ID. So then what you do is you'd send a patch request with like only the fields you want to change. And then there's also like some more complicated stuff where you could do like specific, like more like kind of surgical actions on the object, but that's pretty complicated to implement. And I don't think it's very common either. Okay, so here's this table. And you can see that all of these requests, methods, and like some of their properties, like for example, you notice that get actually, when you're sending the request to the client, the server, right, you actually won't send up a body. And then, yeah, all of the responses have bodies. And safe, what that means is the request will not modify the state of the backend server, right? So get, right, you're just reading data basically. So that's like a non-modifying operation. But right, post, put, and delete, like those are all modifying operations, which is why they're not safe. And next one is idempotent, which basically means that you can do the request twice with the same effect as doing it once. So for example, if you get twice, right, you're just gonna get the resource twice, and nothing's gonna happen after that, right? And then post, right? You can't do it twice, because if you try to post twice, that means you've actually created 2 new resources instead of 1, right? And then put, right? If you like replace once and then you replace again with the same new object, that basically does the same thing as only doing it once, because on the first time you've already done the replacement, you have your new object, right? And delete, right? If you delete an object and then it goes away and then you delete it again, right? That's just the same thing as deleting it once. And so like this is just sort of something to keep in mind when you're dealing with like conditions like network packet dropping, where maybe you're requesting get through, and it's just the most risk is when you don't have an idempotent operation, and then you have to make sure it only happened once, right? All right, and
Wait,
so
Eric, can you? I mean, I don't know if you're planning to, but I never heard of a couple of the keywords that on the last slide. Could you like
oh
briefly talk about if you know what they even do?
yeah, this is just part of the table when I copied it, but like these honestly, these are very rarely used, and I don't think you would really encounter them when you're developing something like a web app or a mobile app. So yeah, just you can do your own research into them if you want, but
Mhm.
they're not terribly important.
Fair enough. And put and patch. So patch you use when you want to like update like part of like if you have like a JSON object in your table, for example. If you want to update only like part of that JSON object, you use patch, and if you want to update the whole thing, you do put. Is
Yeah,
that right?
right. Put you have to provide the
The whole
complete
thing.
resource, like with all the fields. Patch, you only have to supply what you want to change. And there's actually like I mentioned, there's a version of patch where you can actually like instead of just giving new values, like you can actually like move values around and just basically like do like whatever you want to this object. But it's pretty complicated, and like yeah, you can do your own research into it. Um, okay, so next is path and query string parameters. So oh, 1 second. Okay, so what these are is uh like a different way to send more data with your request, basically. So path parameters, usually they're used for required parameters. And like one of the main use cases for path parameters is say like you have a customers collection of customers, and then you want to get like one specific customer. So then what you would do in this case is you would, so say that the customer had ID 10, right? You would do get customers/10, and then your backend code would be able to pick out this parameter and use it to query the database or wherever your customer is stored. And the other thing is query string parameters. And one more thing, the path parameters, like they're just given straight up as like a string or an integer, right? There's no like key like name for the parameter. You just know what it is based on where it occurs in the URL. And then for query string, it's different because there are actually key value pairs which have a key, which is the name of the parameter, and then the value, right? And then path parameters are basically required, like, right? It doesn't make sense to get a single customer if you do not supply the ID. But right, you can query the customer's collection, but then you can also do like optional actions like filtering. So for example, this would be a filter, right? You get all the customers whose name is Bob, and right, this is just a syntax with a question mark and the key value pair is separated by ampersands. So this one would get all the customers whose name is Bob and whose age is 30, basically. But the key thing about query strings is that they're optional, right? The request usually should make sense if you didn't have this, right? Or if you didn't have, certain queries strings and you had others. All right. And then the
You have
last
you have
kind,
a question in chat?
oh, uh, sorry, what was the question? Let me check it out. Oh, that was by the, okay, I should have been watching this. Let me see. Like,
Sorry, it was
okay,
a while back. You don't have to go back. It's fine.
okay, oh, cacheability, basically, this is also like something that's not really, important. Like caching is just basically like when you do a get, right? You have the right data that you got from the get, but then like say that you wanted to keep around the data for using without having to make more requests. So basically a cache, you can do that, right? But yeah, I'm not actually sure what caching for post means, but
When you, I think when you made it composed on the response body, you get what you posted, so you could just keep that around, right?
um
You don't
You,
always
you
get, you don't
okay, I
always
think wait, I think it would be the same thing for patch though. So
do you get do you
yeah.
get well when you patch, you might get like what is the result, but you
Mhm.
don't get what it was before. So like I feel like that has to do with it. I think like the post, you create it and then you cache exactly what you created, and then the patch, the thing changes.
Um, I'll have to do more research on this, honestly.
Yeah.
But yeah, I
I
mean,
think the
caching
get. I
like
mean, the get's the most. I think the get's the only reason you'd cache it is if you don't want to make too many requests, you get something and then you keep it around on your application for as long as you can without getting it again, so you don't have to call it too many times. That's actually used. I mean, you do that a lot in development. You make a get request and then you keep it around for as many times as you need to use it before, without making any requests.
Yeah, yeah.
Alright.
I understood the get. I was just confused. I just saw the table and I was just confused why the post was also like cacheable. Like, what would they use for that exactly would be? That's why I was just confused. But yeah, that makes sense. Thank you.
all right, cool. Let's see. Okay, so the last kind of parameter is a header parameter. So if you see like in this request, you have all these header parameters like the host, the user agent, right? Basically, like the user agent is like what you're making this request with, which is in this case Firefox, basically. And like accept is like what kinds of response formats you can accept. But this is all like pretty technical information, and you don't really have to think about it a lot because most of it just is generated automatically by your backend or your front end. Yeah, and then the one thing you do have to worry about is authentication. So usually when you have authentication, like a token, that will be sent in the headers. And also if you have cores, which is cross-origin resource sharing, which is what I'm going to talk about in my next slide. So yeah, and as you can see, requests and responses both can have headers. Okay, so cores, I'm sure like probably a few of you have already encountered cores before when you're trying to develop your backends. And cores, like it sounds scary, but actually when you look into it, it's actually not that complicated. So like the configuration, the rules might be complicated, but the general idea is pretty simple. So it's basically a security feature that web browsers implement. And it's based on headers. Okay, I should explain it first. So basically, if you see that like you go to a website, right, which is this web document, and this web document, you get it by going to domain A, right? So what would happen is like your first get request would actually be to get like the HTML and everything for this website, right? And then this is called the main request, and basically this determines like what origin your front end website is at, right? And then and once that happens, you can keep making more requests to this same origin, right? So like say if your backend was at API dot api.domaina.com, you'll be able to get, without restriction from that API. But then say that you also have, other resources that you would get from another domain called domain B, right? And then, so this is what would be called a cross-origin request, right? So the website sits at domain A, but then the request, the destination is domain B. So so then that's different. And then the browser then, for security reasons, so if domain B does not allow requests from domain A, then it would actually block those requests from happening, right? And then basically the way this happens is there are headers, a few headers that control this called like access control, allow origin, and a few others. And basically you can restrict the origin of the request, and you can also restrict which HTTP methods are used by that request, and the which headers can be sent. And so usually the solution to this is just to have your backend at the same domain as your front end, right? So if you have domain A, you have api.domaina.com, and otherwise you just have to like set up the core's rules appropriately to make sure that all your requests can get through. All right. Yep.
Eric,
Question.
where do you set up your core's rules?
Okay. Yeah. So the chorus rules are basically all done through this set of headers. Like I can't remember off the top of my head all of them, but these basically would be returned in your responses from your backend. So your backend, right, on all your responses, you would, for example, return access control, allow origin, equals star, which is everything, or equals domaina.com. So that just that key value pairs will tell you like all the rules for cores, and then the browser will read those and decide whether to block or allow requests.
So it's exclusively like based on like the headers of the responses, right?
Yeah, the browser will handle all of that. It's just basically like a security thing that browsers do. Yeah, that's basically the gist of it. All right. Okay, so next would be response codes. So when you get a response, there's actually a numerical code that tells you like information about what happened with that response. And these are generated by the backend, and then the front end gets them and basically makes decisions based on those response codes. So the three like high level categories of response codes are 200, 400, and 500. There's like other hundreds like 100 and 300, but they're rare. So 200, basically what that means is success, like whatever you did, you wanted to do, it went through and there's no problems. 400, what that means is the client tried to make a request, but there's something that is incorrect about that request that the client did. So for example, if you like send a request that has like malformatted JSON, right, that would basically be a bad request. Or if you do not have permission to do what you wanted to do, that would be 403 forbidden, right? And then also 404, and then a few others. And then when that happens, the client basically should correct their request and resend it, and it can still succeed after that. And then 500 is server errors, which should not happen normally. So these would be things like network timeout. So maybe if like your internet was down and then you cannot communicate with the backend server, or if your server crashed and is down, that would also return 500, one of these 500 codes. And it usually means that something is broken, right? And then if you're like a company with a backend, like you really like want to minimize as much as possible the frequency which 500 errors happen, right? Okay. Oh, and also one more thing. So there's actually different kinds of 200 requests. So 200 is just a general like okay request response, and then 201 is actually what you would get when you create a new resource, for example, with a post request, and that gets returned with a like telling you that, you know, hey, there's a new resource that got created, right? Okay, so here are now just some of the different ways that you can design APIs. So like one trick you can do is that the collection view does not need as much detail as the individual resource, right? So for example, if you do a get on, for example, if you had like a Reddit, right? If you had posts and then you do get on them, right? You get a list back of, so this is only a single element list, but you know, realistically, you would have like more elements in this list separated by, you know, commas. You get the ID and only the title, right? Because if you imagine like when you're scrolling through like a list of posts on Reddit or something, the bodies are not actually needed at that point, right? Only when you click into a post do you need to see the body. So actually, when you're doing the collection API, you can actually return a subset of the fields of these resources. So right, if you only give it the titles and say the body was something really long, that actually saves you from having to, you know, send over all that data, which most of it, say that like the user clicks into one post, but then like there were like, you know, 20 posts in the list before that, right? You don't want to load all of the bodies for those other 19 posts when chances are you're never going to need it anyway. So then what you do is when that user actually clicks into a post, right? You know the ID from that collection request. And then what you do then is you would use that ID to make another request to get the specific resource. And then that will have the full details of that resource for you to display on that next page where it's just the one post. All right. Yeah. And the next topic I'll talk about is pagination. So like when you have a really big collections, like for example, if you're Reddit, right, you have that post endpoint, but actually that post endpoint will give you, you know, everything that all the posts that, you know, were ever posted on Reddit. So basically that's a huge number. And what you don't want to do is when you return that return this result, that you return all the posts in existence, right? Because basically that would be like a super huge set of results, and you don't want to transfer all that data, which would take forever anyway. So what you do is you would split up the results into pages. So like, for example, just getting the first 10 posts and then this next 10 posts and then the next 10 posts, stuff like that. And then so one way you could do it is you could, you know, give it an offset plus a page size, right? So for example, if you wanted to get the first page, your offset would be 0. A size would be always be 10, right? If you want like, you know, pages with 10 posts, that would be size 10. And then offset would be first 0 and then first next 10, right? 20, 30. And then that would, you know, let you, you know, get all the posts in sequence, right? But then the thing is it's pretty bad performance on large data because actually what it needs to do is it needs to read through the entire offset. So basically it has to like go down all the way up to that page and then like pick out the, you know, 10 or however many you want. And so when your data gets large and you have to go back far back a lot of pages, right, it has to actually like linearly like crawl back through. So then the performance is going to slow down if you have large data. And the other thing is page drift, right? So So like say, for example, you got the 10 most recent posts, and then what happens is while you were using those 10 posts, someone made a new post, right? So then what would happen is when you get the next page, the first entry in the second page would actually be a duplicate of the last entry in your first page. Does it make sense? So like the pages, like they got pushed down, like the post, they got pushed down by that new post, which would appear at the very top of the first page if you query the first page again. But then what that did, right, was basically it made and like pushed one into the second page, so it appeared twice. And then another thing that could happen is, for example, if you're reading the first page and then one of the posts in the first page got deleted, then what would happen is when you go to the second page, there would actually be a hole, right? Like there was a post that was outside of the first page when you got it, but then when you're getting the second page, right, it's no longer in the second page either, because like when you deleted from the first page, it moved into that empty spot, right? So that's called page drift, and it's basically just remember, like it's an issue that you can have with offset plus size. And then like the newer like better way to do it is key set pagination. And that's better for large data because you can just jump straight to the data without going through everything basically. And the disadvantage is that you can't jump to an arbitrary page. So like you can't say, hey, I want page 50, right? You would actually have to go through all the pages to get to 50. But in the most common use cases for like these all these web apps, like which is basically like infinite scroll. So like if you get to like Instagram or something, like you can just scroll and scroll forever. Like this is a good use case because you always have a continuous path from the the first page down to like whatever page you get to. And basically what's happening behind the scenes is, right, the app is requesting like new chunks of data as you go down. So yeah, and just a little bit about how to implement key set pagination. So basically, right, you would give it a parameter to the API called limit, which is basically the size of your page. And like your first request would be do a get on posts, and just assume that the posts are ordered in descending time order by default. So if you just get the posts and limit 10, right? So in the backend, this would basically be what the SQL would look like, right? Select all of the fields from posts ordered by time created descending, limit 10, so that would give you the first 10. And then what you do for your second page is, right, you would look at your first page and then you would figure out which was the last ID, right? So what you do then is you would send in the last ID as a query string. And then when you have, when you in the backend, when you try to give it the second page, what you do is, right, since it's ordered by time created descending, you would first figure out, like with that ID, what the time created of that last post you return was, right? And then you use the result of this query to do another query where, right, you get from the post where time created is less than or basically before the last entry in your first page, and then right, the rest is the same. And so this will basically allow you just to like step by step, climb down the list of results, but then like at every time, right, you can just go straight to where you left off without having to search through the data, right? Okay, yeah, I think that was my whole presentation. Did anyone have any questions?
Go time.
Eric, I don't know how much you know about GraphQL APIs, but can you talk a little bit about any differences between them?
Oh, sure, yeah. I'm personally not terribly familiar with GraphQL, but yeah, like I said before, like there are different kinds of APIs. Like for example, there are like RPC APIs, remote procedure calls, where basically like all your requests are post requests, and then your URLs in that case, they actually would be actions. And there are other kinds of APIs called like WebSockets, where there's like a continuous connection between the client and the server, and then the server can initiate like data exchanges. But yeah, like there's just different kinds of APIs for different use cases, but like REST is just pretty common one that is pretty widely used.
What's REST? Do you know what's like REST best used for? Like, what's this like best case scenario?
So the best case scenario would be like basically an app which doesn't require continuous transfer of information. So like basically like for example on Zoom, like we're on Zoom right now, like we have like a continuous video link, right? There's constantly like audio and video being transmitted. So, or if you have like some like real-time chat application where like you're sending messages, but then you're also getting messages, that requires two-way communication, right? So, and that has to be happening all the time. So that would not be a good fit for REST. REST is basically just when you're basically maybe like scrolling through, a Reddit page or, just doing things that don't require, like if you think about it, it's pretty simple. Like you can figure out like what requires continuous data transfer and what doesn't.
Yeah, and for the continuous data transfer, you would probably use WebSockets for that, most likely.
Yeah, WebSockets or like, honestly, they're probably like specific protocols for audio and video.
Yeah.
Yeah, there's a lot of different stuff that's out there.
When would you use like GraphQL over REST because they're pretty similar? They're not like the nature is not like continuous communication.
I think GraphQL is just like is just sort of an optimization. Like from what I've read about it, it's like for example, the example that I had about the collection returning a summarized view of the data instead of the full data, right? I think GraphQL what it does is just that takes it to another level where like you actually like specify like which pieces of data you want. But I don't know, like, yeah, I have to do more research into it because I'm personally not too familiar with GraphQL either.
Yeah, makes sense. Well, thank you.
Okay, well, any more questions? All right,
Yeah. So like,
oh, go ahead.
it's like example with pagination. So like you said, like you get like 10 posts, and then for the next request, you just like pick up where you left off and then just get the next 10, right?
Mm-hmm.
So like what happens if like the last post got like deleted or something? So you like picked up 10 and then like the 10 posts got deleted. Or
Yeah,
like
so yeah, so you're saying like if last ID 3, so if post 3 got deleted
yeah.
between your first request and your second request, yeah. So I think like basically what you do is like, as you know, like when you delete something on like Facebook or Reddit, like it doesn't actually get deleted, it just gets like marked as deleted, right? So like if you just right, do a get from the post, right, there's gonna be like a filter or something that you know just lets you only see posts that haven't been deleted. So but this will still work, right? So if you could just keep this post somewhere else, right, because all you need is the time it was created, and like if you keep that data around, right, there it wouldn't be an issue even if it was deleted, right? You would just put some logic in your backend to say like how if this post was deleted, then I'll just go somewhere else to find that.
All right. Cool.
Okay, all right, so the last thing we have today is a Kahoot. I hope you're all paying attention.
Oh no.
Okay, so let me get that set up real quick. Um, okay. Oh. One second. I just have to go through these options. Okay. 1 second. Okay.
Wait, Eric, how are you playing? Isn't that cheating?
No, that's not me.
We're missing two.
Yeah, who is it doing?
Mehul here.
Yeah.
Yash. Just Yash, right? And that's Yash's I love you, Eric.
That's everything. Eric's not joining.
Wait, Tiago, where? Oh, are you in here? Oh, there
I'm
you
in
are.
there. Wait, who just
Okay.
left? Come on.
Wait,
We should only have 12 because Eric's not joining.
Oh wait, so it should be at 12. It should
Wait.
be 12. Who just left? No, but Eric's already there. Oh, is Eric not Eric?
No, Eric's not.
no, I'm not Eric.
Okay, just start. We only have 15 minutes.
Okay, someone doesn't want to play.
Whatever,
Sad.
just start.
Okay. What do we got here? Yeah, there we go. Right, you see how that is? When you're doing a post, you should post to a collection, right? You would do post customers. The ID doesn't exist yet when you're creating a new object, right? For all the other ones, you can like it all acts on existing objects, but only post creates a new object, which is why you can't put an ID in the request, right? Oh, agent, let's go. Client errors. Yep, looks like everyone got that right. All right. Oh,
Hey,
Ethan-
Ethan, not so
Ethan
quick
lost
this
his
time.
lead. Not good, not good. All right, let's see the next one. So this is the new good kind of pagination, not the bad kind of pagination. Okay. Oh, it looks like I moved in first. Shouldn't be too hard.
Eric, how you got true or false for a yes or no question?
Oh, I mean, it's basically just yes or no. I mean, it makes sense. Yeah, so look, right, in REST APIs, you always want to act on objects, not on verbs, right? Create customer is a verb. So anytime you see a verb, that should tell you, hey, that's not a REST API. That's something else, right? Okay, let's see. Oh, I've answered 4 correct answers in a row.
But it's not fair. You made this. You made the Kahoot.
Sorting and filtering. Yep, query strings, right? Because it's optional. Wow, still me. Okay. Okay.
Wait, sorry, got that
It
one
looks
wrong.
like I lost. Yeah, I think I lost that one. I went over this, so you should all know it. Yeah, right.
Wait,
201.
what? Wait,
Yes,
what?
200. Like I said, I went over this very specifically. 200 is the general success request response code,
That's
right?
bullshit.
But then
Nah, that's
201
bullshit.
201 is just more specific, right? Right? 201 actually tells you that something's been created, which is what happens when you post. Make
Bullshit.
sense? Yeah.
I refuse it.
Oh, looks like we got some stuff mixing up. Oh, Jeff QL got a 3 streak. Okay. Yeah, header, right? Because you send tokens in something like authentication or authorize. And there's actually like an authorization header, I think. Yeah. Okay. 5 huh? Braden has a streak as well. One person got this right. What happened? Right? Your query strings, right? You have, question mark name equals something. That's the key value pair.
Eric, I thought this meant that the query string was the key and header was the value.
Yeah.
No. Right? These are types of parameters. A query string is a type of parameter, right? And a header is a type of parameter.
I think the
So
question-
these
No, that was a bad question because I thought it was asking, like, there's one of them is a key and one is a value, and I was just super confused.
I mean, someone got it right.
Dude.
Right? This makes sense, right? The headers, right? You have like access control or content type equals JSON, or query strings, right? You have like key value pairs. Right?
I mean, the wording was confused. Go
Okay,
next.
well, I talked about it a lot in the actual lecture too. So where were you? All right. You get more chances. How many more questions do we have left? Let me get my doc back.
Hurry up! It's 6:23.
Hold on, yeah. My doc was here. Okay, still vibe. Let's go. I have 5 more questions.
Dude, I don't remember.
Just think about it. Just think about it. You can reason it out. Yeah, right, post, right? Because I talked about this post. When you do it twice, you're gonna get two objects, right? If you do get, put, or delete, those can all be done twice without a different effect than once. Okay. Still live on. Huh? Yep, right, 500 server errors. Okay. Yeah, right. Get, you just tell where to get the data from. You don't actually send anything up with it. Oh, we got a new leader, Jeff QL. Let's go. I'm in second. I'll get up there soon. Yeah, right. Course is all about cross origin. All right, I'm catching up. Yeah, both, right? When you're creating an item, it shifts the pages down, like all the items down, and when you delete, it shifts all of them up. So either of those could affect what appears on the next page. All right. Okay. All right, last question. So whoever wins after this is actually gonna win. Yeah, I can't jump to page, right? Because with key set pagination, right, you can only go step by step to the page you want to get to, but you can't jump. All right, let's see. Okay, third for me, Jeff. Oh, it's Braden.
Wait, Braden just came through on the very last one?
What?
Dude, Braden was just sneaking up on there and he just boom on the very last one.
Scargo, are you gonna Venmo Braden?
Unfortunately, there was no prize this week, but you get a personal congratulations from Eric Tang. Go ahead, Eric. I'm just kidding.
Congratulations, Braden. Clearly, Braden's been paying attention where many others have not. So congratulations.
All right, y'all. Thanks everyone for coming. Thanks Eric for putting up together this Kahoot and the awesome lecture. I will see you guys tomorrow. Some of you guys tomorrow. Bye bye.